All right, for this last lesson of this module, we're going to go ahead and apply literal equations, okay? So our goal is I can apply literal equations to real life scenarios. So here's the same vocabulary that we've been going over from our past lessons. Just know when working with formulas in real jobs, it is often much faster to solve for the unknown variable first and then plug in your numbers. So let's take a look at some of these examples. Okay, not all of these might be 100% accurate with which formula we chose, but this happens a lot with actual formulas in real life all the time. So the target heart rate H during exercise is calculated by using the formula H equals 220 minus A, where A is the age of the athlete. So let's solve the formula for A and then find out how old the following clients are. Okay, so we're going to start with the H equals 220 minus A. And so we want to solve for the A first. All right, so we're going to go ahead and subtract the 220 from both sides. And we get, I'm going to bring that over here. H minus 220 equals, oops, let me fix that. Equals negative 8. Because we have the minus over there still. And we don't want the minus to stay there. We want to know what positive A is for their age. So we're going to divide everything over here by negative 1. So we end up getting negative H plus 220 equals A for my formula. Okay, so now all I have to do to find the age of all these different clients is I just have to go ahead and take in their beats per minute and plug it in. This is your H. We're going to do negative 175 plus 220. So negative 175 plus 220, which would equal 45. So the age of this client is 45 years old. So instead of having to plug it in and solve it every time, we can just plug it in like this and get the answer. So let's plug in 150 in for H. So we get negative 150 plus 220. Okay, and then in this case, negative 150 plus 220 is 70. And then client 3, we're going to plug in negative 135 plus 220. And we get the client is 85 years old. So oftentimes it's just easy to solve the variable of what you're looking for and then plug the number in. Okay, this one was pretty basic, but that's an example of what you could use. So let's look at another one. A police officer investigating an accident uses the distance formula D equals RT to calculate driving speeds, where D is the distance in feet and R is the rate or speed, and T is the time in seconds. Okay, so first let's solve the formula for R, then find the speed for the following drivers. So if we have D equals RT, we want to find how fast they were going. So we're solving for R. We're going to go ahead and divide both sides by T. And that cancels out. And there's our formula that's left. We're going to say R equals D divided by T. That's how you can find the speed. So driver 1, the skid marks show the car traveled 180 feet before coming to a stop over a span of 3 seconds. So this part right here is my distance. This part right here is my time. So the rate equals 180 divided by 3. So 180 divided by 3 is 60. So that tells me that this car was traveling 60 feet per second. Okay. Driver 2, skid marks show the car traveled 240 feet before coming to a stop over a span of 5 seconds. So here is my distance. Here is my time. So we're going to do 240 divided by 5 to figure out what our speed. Okay, so let's see. 100 divided by 5 is 20. 200 divided by 5 is 40. 40 divided by 5 is 8. That gives me approximately 48 feet per second. Is how fast that car was coming as it was trying to come to a stop. Okay, so there is another way you could use this. And let's do one more way. The event planner. An event planner calculates the total cost of renting a banquet hall using the formula C equals 50G, 50 times G, plus 300, where G is the number of guests, and $300 is the fixed cleanup fee. Solve the equation for G to see how many guests the following client can invite based off their budget. All right, so we got 50G, so C equals 50G plus 300. And we want to solve for G because we want to know how many guests we can invite if we have a certain budget. So first thing we're going to do is we're going to minus 300 from both sides. So I get the cost minus 300 equals $50 per guest. Now we just want G by itself. So we're going to go ahead and divide by 50 on both sides. And we get G, so the 50s cancel out. So we get G equals the cost minus 300 divided by 50. So that's how I can figure out how many guests I can invite in this scenario. So let's come over to the first client. They have a budget of $1,800. So the guests is going to be 1,800 divided by 300 divided by 50. Okay, so 1,800 minus 300 is 1,500. Let's go ahead and write that down. We got $1,500 divided by $50 per guest. And 1,500 divided by 50 is going to be, well, if I'm doing it in my head, I can cancel out the zeros. And 150 divided by 5 is 30. So you could invite 30 guests into this banquet. Use a calculator if you'd like to. There's no big deal with that. Let's do it again. We're going to do 3,300 minus 300 divided by 50. Okay, 3,300 minus 300 is 3,000. Divided by 50. Okay, so let's go ahead and punch that into your calculator if you need to. And what do you get? All right, hopefully you are getting 60 as your answer. Okay, 3,000 divided by 50 is 60 guests. So if you have a budget of 3,300, you can invite 60 guests. All right, let's do it one more time. This time you have a budget of 4,800 minus your 300. Oops, yeah, that's right. Let's go back and fix that. So 4,800 minus 300 over 50. Okay. All right, so 4,800 minus 300 is 4,500. We're going to divide that by $50 per guest. And that will get me a total of 90 guests that I could invite to that banquet. Okay, so there's just some examples of why we might want to solve for a variable first and then just plug in the answer. You can either do it in a calculator if you want, do it in your head, whatever works for you. And so let's take a look at our goal. I can apply literal equations to real life scenarios. So go ahead and work on your assignment and reach out if you have any questions.